Good morning, students. In the last class, you have seen what about rational numbers and their properties and everything. And today, first we recall all the definitions again, and then we are going to the next session, right? So we are going to recap all the definitions now. So rational number, we have seen what rational number. So what is rational number? So rational number is nothing but in the form of p by q, where p and q are integers and the denominator is not equal to 0. And these are some identity property. That is, identity of rational numbers under addition is nothing but 0, because if you add anything with 0, the result will be the same number. So that's why 0 is called identity element under addition. And similarly, in multiplication, 1 is the identity element. That is, if you multiply a rational number with 1, you will get again the same rational number. That's why 1 is called inverse element. That is, identity element of rational numbers under multiplication. So next, inverse. So inverse of element, that is inverse of a rational number, is nothing but the negative of the same. Because if you add a rational number with the negative of the same, we will get 0. That's why the inverse of a rational number is nothing but negative of the same. And under multiplication, that is, if you multiply any rational number by its reciprocal, you will get the answer 1. So that's why the reciprocal of a rational number is called inverse of the particular rational number. So this concept, everything we have seen in the last classes. And one more thing we have seen in the last class, that is properties. So what are the properties are there? Closure property, commutative property, and associative property. So identity and inverse we have seen in the last slide. Now we are going to recall the properties closure, commutative, and associative. So we have seen in the last class all the properties are satisfied under some operators or not, right? Let us recall everything here now. So first, closure property. The closure property satisfies in all operations. That is addition, subtraction, multiplication, and division. That we have seen in the last class. And similarly, commutative property. The commutative property is nothing but in under addition and multiplication only that will be satisfied for rational numbers. But under subtraction and division, it not satisfied. And associative property also under addition and multiplication, but not subtraction and division. So this everything we have seen in the last classes. So today we are going to see one more property, is nothing but distributive property. So what is distributive property? So there are two cases are available distributive property. So first one, multiplication over addition. That is, here we are going to see the property with the two operators at a time. So first one, multiplication over addition. So that is a property. For distributive property, we need three rational numbers. So they are A, B and C. So here A, B and C are any three rational numbers, right? So if we operate them like this, so first one, out of the bracket multiplication and inside the bracket addition. So this is called multiplication over addition. So this is the equivalent value, that is A into B plus A into C. That is multiply A inside the bracket, that's it. So A into B plus A into C. So that is the first property of distributive. And second property is nothing but multiplication over subtraction. So instead of addition, the subtraction symbol will come. So that is, so A, B, C, and here multiplication over subtraction. If you multiply A inside, so A into B minus A into C. That will come like this. Okay. Now we are going to verify the distributive property with an example. And before that, yes, verify distributive property by taking A, B and C. We are going to verify the two distributive property by taking A value, B value, C value like that, right? So first one. So in the first case, multiplication over addition. So here, look at here. In multiplicative property over, that is distributive property, multiplication over addition is nothing but A into B plus C. That is, both sides are there, left hand side and also right hand side. Now we are going to find out the value of left hand side and right hand side separately. Then finally we are going to compare the solutions, right? That is, finally we are going to prove they are equal. Okay. So listen now. So that is a question. So solution now. So that is the left hand side of distributive property, right? So now substitute the numbers. That is a value is nothing but what's a value in the question? So a value 2 by 3, b value 5 by 3 and c value 4 by 3. Now we are going to replace a, b and c by these numbers. So that is the value of the left hand side of the property. So here I just substituted the value of a, b and c, right, with the particular operators. Then in the next stage, here always first we have to simplify the numbers inside the bracket, right? So here inside the bracket 5 by 3 and 4 by 3 are there with the addition symbol. So in the next stage we are going to add these two rational numbers. So if we add these two rational numbers, look at the denominator, so they are same. So therefore it is enough to add the numerator directly. Once again repeat to you, in the last class itself I said, here I took the numbers with the same denominator, that is like fractions, because of time being, right? So whatever it is, if the fraction or if the rational number or unlike fractions means, you can take LCM and then simplify it, okay? Right, 2 by 3 into, after simplify the numbers inside the bracket, we get 9 by 3. So next multiplication symbol between these two rational numbers, so multiply them. So how can you multiply? Numerator with the numerator and denominator with the denominator. So 9 2s are 18, 3 3s are 9. So 18 by 9. So that is the value of left hand side of the first operation, right? So next we are going to find out the right hand side value of the distributive property. So a into b plus a into c. Now again we are going to substitute the value of a, b and c as it is. So look at here. So instead of a 2 by 3, instead of b 5 by 3, again instead of a 2 by 3, instead of c 4 by 3. Now we are going to multiply. So first simplify the numbers inside the bracket. So here two rational numbers are with the multiplication symbol. So we are going to multiply first. Similarly here also, right? So 5 2s are 10, 3 3s are 9. Then this plus, and then 2 4s are 8, 3 3s are 9. Now we got two rational numbers with the addition symbol. So we are going to add these two rational numbers now. So look at the denominators. They are same. Therefore, it is enough to add the numerator directly. Suppose the denominators are different means we are going to simplify with the LCM, right? So 18 by 9. So 10 plus 8, 18. Here 9. So 18 by 9. So left hand side result 18 by 9 and right hand side result also 18 by 9. So therefore the property of multiplication over addition verified. So what is the next one? So second property of distributive, that is multiplication over subtraction. So multiplication over subtraction, I took the same number, right? A value 2 by 3 and b value 5 by 3 and c value 4 by 3 likewise. So now the symbol is different here, okay? Now I took the left hand side value, that is left hand side expression of the property. I substituted a value 2 by 3 and b value 5 by 3 and c value 4 by 3 as it is. In the next step, we are going to simplify the numbers inside the bracket, right? So here, look at the denominator, they are same. Therefore, it is enough to subtract the numerator directly. So if you subtract means, what will come here? So 5 minus 4, 1. So 2 by 3 into 1 by 3. So after subtracting, we got two rational numbers with a multiplication symbol. Now we are going to multiply these two rational numbers directly. So 2 into 1, 2 and 3 3s are 9. So 2 by 9. So that is the value of left hand side of distributive property, second property. Next we are going to find out the right hand side value a cross b, that is a into b minus a into c. Again replace a value, b value and c value like this. Okay, now multiply the numbers inside the bracket and here also multiply the numbers inside the bracket. Finally subtract it. So if you multiply, so 2 5s are 10, 3 3s are 9 minus here 2 4s are 8, 3 3s are 9. Again we got two rational numbers with a negative sign, that is with subtraction sign. So we are going to subtract it. So when you are add or subtract, so before it is better to look at the denominator, right? So the denominators are same, so it is enough to subtract the numerator alone. So 10 minus 8, 2. So 2 by 9. So look at the results. So left hand side 2 by 9 and right hand side also 2 by 9. So the both results are same. Therefore, the distributive property of multiplication over subtraction also verified now. So that is a procedure to verify the property, right? So next example, that is also related to the distributive property only, but here no need follow the distributive property, but we want to follow the concept of distributive property, right? So look at the example, simplify 4 by 5 into 2 by 9 minus here, that is 1, 2, 3, 4, 5 rational numbers are there with some, that is addition, subtraction, multiplication, everything over there here. So how can you simplify this? So before simplifying these kind of questions, first check how many terms are available. So terms, how can you find out the number of terms? So in an expression, every terms, that is terms are divided or classified by the operators addition and subtraction only, not multiplication, division. So once again repeat, in an expression, how can we classify the terms? Means all the terms are classified by the operators addition and subtraction, not multiplication and division, right? So look at here. So how many terms are available here? So this is the question. I splitted the terms, that is subtraction symbol is here and addition symbol is here. Here multiplication. As I told already, the terms everything classified by subtraction symbol and addition symbol. So here subtraction symbol is there, so that I splitted this with the bracket, and after subtraction here addition is there, so I splitted this number alone, and finally this term. So how many terms are available here now? 1, 2, 3. So 3 terms are here. So how can we simplify this? So first and after that, so here in the first term and last term. So look at the first and last term. So two numbers are same, right? That is here also 2 by 9, here also 2 by 9. So now we are going to arrange, that is rearrange the terms, right? So 4 by 5 into 2 by 9, and the third term will be the second term now, because according to the same terms, right? So both terms are having the same term. That's why I wrote that is in the successive order, right? And I kept the second one as a last one. The next, in first and second term, 2 by 9 is a common one. So take 2 by 9 out of the bracket. That is, we are going to take 2 by 9 as a common one. So in the first two terms, I took 2 by 9 as a common one. So remaining here 4 by 5, this plus, and this 8 by 3 minus this 1 by 7. So next we are going to simplify the numbers inside the bracket, because already I told that the numbers are there inside the bracket, means first simplify that one. So 2 by 9, so 4 by 5 plus 8 by 3. So look at the denominators, they are different, so that I took LCM here. So the LCM is 15. So the first term, it is enough to multiply with the 3. So 4 3s are 12. Similarly, second term multiply with 5. So 40. So minus 1 by 7. In the next stage, 12 plus 40, 52. So divided by 15. Here 2 by 9 minus 1 by 7. Again, these are the multiplication process. So multiply them. So 104 by 135. That is 2 into 52, 104. 9 into 15, 135. And minus this 1 by 7. So after subtraction, so here also two rational numbers with the negative symbol. That is subtraction symbol. So look at the denominator. They are different. So that I took LCM. So the LCM of 135 and 7 is nothing but 945. Or you can make a cross multiplication. That's better. So 104 into 7, 728, and 135 into 1, 135, and divided by multiply the denominators 945. And if you subtract the numerators, we get 593, and the denominator 945. If you want to simplify this term, means you can simplify. Is it possible? Means otherwise leave it. So how can you simplify this kind of expressions? Means first you have to find out the number of terms, then after that in the second stage combine the like terms. That means combine the terms which having the common number, then after rearrange the terms, take the common number out of the bracket and write the remaining one inside the bracket and simplify. So that is the procedure.